Alright, so today we're going to be talking about graphing piecewise functions. So this is where our graph is kind of divided into different functions depending on certain parts of the domain. Okay, but I'll get to that in a second. First of all, I just kind of want to, let's say I'm given two functions, and let's just try graphing just these two functions as they are. So let's say I'm given x plus 1, and let's say I'm given f of x is equal to 2x. Okay, so just really basic functions. So I'm just going to graph these individually. So I would start at the y-intercept, right? Or if you want to, you can make a table. I mean, you could. These are just linear functions though, right? So I'm just going to start at 1, and then the slope is just 1 over 1, right? So it's going up 1 over 1, or it's going down 1 left 1. So just your typical linear function, and it would look something like this. Okay. Then for 2x, it doesn't have a y-intercept, so you start at 0, and this one's going to go up 2 over 1. Okay, or it's going to go down to left 1. So that one's going to look something like that. Okay, so very similar lines. This one's just a little steeper than the other one. But let's say, and let me zoom out here a little bit so we can kind of see everything that's happening. So let's say that it gives me these functions. So f of x is equal to x plus 1 when x is less than or equal to a negative 3. Okay? And it is equal to 2x when x is greater than a negative 3. Okay? So this is what we would call a piecewise function. I'll zoom back in here a little bit. So basically, it's giving me two different functions and a range. So these both have a domain of negative infinity to infinity, right? But this function in this situation would have a domain of negative infinity to negative 3. Sorry, that would have a bracket. And this one would have a domain of negative 3 to infinity, with both being parentheses, because it's a greater than. So when I were to look at these, basically this graph would include everything from negative infinity to negative 3, but everything after it would be gone. Okay? It's just this point forward would be what's included. Where on this graph, it wants to take everything from negative 3 with an open circle, because it doesn't quite include negative 3, and include that. So just this little part on the end would no longer exist. But with piecewise functions, it wants both of those on the same graph. So I'm going to combine those two graphs here and put them on the same graph. So this one at negative 3, it was at negative 3 and negative 2, right? So negative 3, negative 2, it was going down 1 over 1. It just wants those values. And I'm going to have a closed circle right here, because it does include that point, because it's less than or equal to negative 3. This graph does not include negative 3, so it would have an open circle at negative 3, and it was at negative 6. So it'd have an open circle right here, and it's going up 2 over 1 the rest of the way. Okay? And that is how piecewise functions work. Okay? So when you see a graph with two lines, and one has a closed circle, one has an open circle, that's a domain basically switching between two functions. Okay? Let's look at an example of some of these problems. Wait, yes. So, let's look at number 7. So number 7, let me zoom in here a little bit. I have a cube root of x minus 2, and I have a square root of x minus 3 plus 1. So again, that's a horizontal transformation to the right 2 spots. This one's going to the right 3 spots and up 1. Now I'm going to start by just making a table with some values. That would work. And then we'll go from there. Okay, so I'm going to do the cube root one over here. So this is the cube root of x minus 2. That's what table this is. And then I'm going to do the square root one over here. So the square root of x minus 3 plus 1. It's going to be this table. And that's going to give me some values. Now I'm just going to make some value, like the normal values I normally would, and we'll worry about this domain and stuff when I try to graph it. So with cube roots, remember I'd always use the -8, -1, 0, 1, 8. But again, it needs to work here. So I have a -2, which means I'd have to move everything to the right a couple spots for it to, move the x's, up a couple spots for it to actually work. Because I want to get this to be a -8 square root, right? So I'd actually plug in -6. -6 minus 2 is -8. Cube root of -8 is -2. Okay, and then I would plug in positive 1, because 1 minus 2 is -1. So I'd plug in positive 1, which would give me a cube root of -1. And then I'd plug in positive 2, which would give me a cube root of 0. And then I'd plug in positive 3, which give me a cube root of 1. And then 10 isn't going to fit. So that's all I'm going to use for that table. Then we're going to come over here and do the square root. So it would have to go up 3 on the x's. So I would be plugging in. So again, with square roots, I used 0, 1, and 4. So this time I'm going to use 3, 4, and 7. Okay. So 3 minus 3 is 0. Square root of that, it would be 0. Plus 1 would be 1. 4 minus 3 is 1. Square root of that is 1. Plus 1 is 2. 7 minus 3 is 4. Square root of that is 2. Plus 1 is 3. Okay. Now there's a table with some values that I can now graph everything. But let's pay attention to our domain. So right here, this first function is all those values that are less than 3. So I can only use these first 3 x values. Okay, just these first 3. So I'm going to plot those points. -6. So 1, 2, 3, 4, 5, 6, down 2 would be my first point. And then it would be 1, -1, and 2, 0. And then at 3, I'm going to have actually I can include all these, but the 3 is going to have an open circle, right? So right here, I have an open circle. So this would be the graph for the piece of my first problem. And then the second one starts at 3, 1. So, this is a dumb graph. So I am going to have a closed circle here. It does continue. And then it'd be 4, 2. And then 7 and 3. It's really not that different from what it would normally be. I'm going to do another one because I didn't do that beforehand, and it just basically looks like a cube root function. Let's Let's do one of these big ones. So I have an absolute value of x plus 2. So that one's going to be all those x values that are less than 0. And then I've got a compound one that's all those values that are from 0 to 1. So like one little stretch. And then f of x equals 4 would be everything greater than 1. So f of x equals 4 is like y equals 4, which would be a horizontal line, right? So I'm going to start with the f of x, the absolute value of x plus 2. And so it's going to start at 2 because that's the y-intercept. And it's an open circle, but this one's starting at 2, 2. So it's going to end up being closed. So I'm just going to put a normal dot there. Okay, but it's all those values less than x, right? But it's the absolute value. So -1, absolute value of -1 would be 1. 1 plus 2 is 3. And then so on. It's going to end up going up still because, again, absolute values are always positive. So it just ends up going up anyway. Okay? So there's my first piecemeal function. And then the other one, from 0 to 1, is 2x plus 2. So it's going to start at 2. And then the slope is 2 over 1. So it would go up 2 over 1. And there is the other one. And that is going to have a closed circle because it does include 1. But then everything greater than 1. So not including 1. Oh, actually, yeah. So it meets the same spot. So it's basically going forever as a constant after that. So it looks something like that. And that is a piecewise function.